Okay, so we can start. So now we'll start with looking at what I call the most important identity. In this course, that is sine squared x plus cos squared x is equal to 1. It looks very simple, and for sure it's very, very simple. Even to remember, it doesn't give headache. Now, when you say sine squared, you can as well write this as sine x in brackets squared plus cos x squared is equal to 1. We mean the same thing. The variable x, you can use a, you can use b, you can use any letter there, to a point where even if we say sine squared g of x plus cos squared g of x, we will still say it is equal to 1. For as long as what is here is equal to what is here, the identity still holds. So you must understand. The next time you find a theta here, don't say, I only know for x. It's just an angle holding. Even if it looks like it's a polynomial, we call it an angle because it's inside sine. Sine deals with angles. So whatever goes in sine is called an angle. Regardless of how it looks, we don't care. So that's the first identity, and we call it the most important identity in this course, in trigonometry, to be specific. Okay, then now other identities will follow. Which other identities? We'll talk about compound identities.
Sir, can you repeat on the last one? My line was breaking.
So we're saying, when we say x, we don't know what x is. Okay, x can be a function. X can be anything. But for as long as it's inside cos, even if it is g of x, even if I say sine squared x power 7 minus 1 plus cosine squared x power 7 minus 1, it will be equal to 1. For as long as these things here are equal, then you get that. That's the meaning of this identity. And it's very crucial. You will see when we begin to study so many things about it, you see what's going to happen here. Okay. We move. Compound identities. 1, if you have sine A plus B, we split it in the manner sine A multiplied by cos B plus cos A multiplied by sine B. It doesn't matter how you arrange them. It can be sine B cos A for as long as you switch the A and B on cos and sine. And for sine function, it maintains the plus. So that if it's to be minus, it will maintain the minus. Take care of that. And then 2, if you are dealing with cosine A plus B, for cosine, you expand in this form, cos A cos B minus sine A sine B. Cosine switches. If you have plus, it will change it to minus. So that if you have minus here, it will be changed to plus the other side. Okay? And then 3, sec A plus B. This one, sec is 1 over cosine. So you deal with cosine A plus B in the denominator. So that if you are dealing with minus here, there will be minus there too. There's no changing here because sec, what is going to change the sign is cosine when you expand cosine. When you're dealing with sec A minus B, you just get 1 over cosine A minus B. Whatever sec is having is the same as 1 over cos. And then 4, if I do with cosec A plus B, it's just going to be 1 over sine A plus B. This means that if there's a minus, use the minus. 5 tan A plus B. Now for tan, sometimes the examiners can ask you to show how tan a compound identity comes about, because we know that tan is sine A plus B over cosine A plus B. So now that we know the expansion of sine, we can have the expansion of sine. So say sine A. Hey, forgot to put my thing on charge. Okay. So you get sine. So get sine A cos B plus cos A sine B over, we now expand cos. So say cos A cos B minus sine A sine B. Okay, and then you divide every piece of this, you divide by cos A cos B plus cos A sine B. You also divide by the same cos A cos B over cos A cos B divide by the same cos A cos B minus sin A sin B over cos A cos B. So if you take a closer look, you will notice that this here can cancel, this here can cancel, and this here can cancel, this here can cancel. So if we simplify this thing, you know, when you have sin B over cos B, that is tan. When you have sin A over cos A, this is tan. When you have sin A over cos A, sin B over cos B, so ultimately you're going to have tan A plus tan B over 1 minus tan A tan B. So that if it was, so that if it was minus here, the minus would just be following up here, and it will be changed to plus on this part. So it could follow in all the steps. Where there's plus, you put minus. Where there's minus, you put plus. So we'd have had minus here, so that we have a minus there, and a plus here, and a minus here, and a plus here. To the last part. Okay. And then the other one, I'll just squeeze it here. If we do with 6 cot A plus B, we'll just say this is 1 over tan A plus B, so that you can follow up what happens if you switched minus here and minus there. These are the only compound identities that we have, but there's so much from these. We can generate so many identities using these 6 by 2, 12 identities, plus the most important one, 13 altogether. So many can come out of these. So now we deepen our study of these very identities.
Sawa, sina mambo zako pambuyo pata pemwe sinenze naona ka picture nitaka kuchukua screenshot. Yeah. All right, thanks Mr. K.
Okay, so we move to some more identities now. As a result of the compound and the most important identity, what do we get? So you can see that if we are to have sin A plus A, you know A plus A is just 2A. When you expand this, there will be A here, there will be A there. So we have same things. This is going to be sin A cos A plus cos A sin A. Nothing has changed. This means that sin 2A is actually equal to 2 sin A cos A. Take note of that. If we went to cos A plus A, then obviously it is just the same as cos 2A. What is it next? Next, it will be cos A minus sin A sine A, so that it becomes cos 2A is equal to cos times cos is the same as cos squared A minus sine squared A. This is an identity. 3, if we are dealing with sec 2A, automatically it will be 1 over cos 2A. So now I want to run through all this. You should be able to pick it up from there, that if you see cosec 2A, you've just seen 1 over sine 2A. Okay, I'll be slow. Tan 2A, if you look at tan, it means that we'll have another A here, and we are adding. So we'll have tan A plus tan A, we'll get 2 tan A over 1 minus tan squared A. So that the time you see cot 2A, you're not just dealing with 1 over tan 2A. Like this. Okay? Then let's bring back the consequences. So call
Sir,
them.
just a minute. Can you
Okay. Consequences of the of the first identity.
So identities yafunika che yali mumutu.
No, you just need just a few, and then the others will be coming as a result of what you already know. Have you seen that so we call these double angles. We call these double angles. When you say 2A. So you've seen that the double angles are just coming as a result of the compound angles. So once I know the compound identities, when I double them, it's an easy thing because I'm just getting the results of the compound one. So once you know this set, then you automatically know this set. I have Africa removed. You need them. You can't start driving every time. But you know, in mathematics, you can't have a whole day of memorizing these things. No. It's the more you do questions on trig that you begin to say, oh, this is just, I saw this. This is sine A plus A. This is just sine 2A. Oh, okay. 2 sine A cos A. Because you keep on writing it, so it will stick. But if you have the whole day, you close your eyes and sine A plus A, sine 2A, this is, they will go. Once you are done, they will go. Okay. Consequences of the first identity. The one we call the most important one. Sine squared x plus cos squared x is equal to 1. You can see that from this one, if we take cos the other side, we'll have sine squared x is actually equal to 1 minus cos squared x. The third one, cos squared x will be the same as 1 minus sine squared x. Excuse. Then let's go back to the first one here and to the second one here, this one.
Basa You are moving so fast, Sky. Like I haven't even.
I said you go back. So that when I get back here, then you'll be done.
Okay.
So now what is here is cos 2a is equal to, so said we have cos 2a is equal to cos squared a minus sine squared a. Suppose we choose to write cos as, cos in terms of sine. We'll have this very cos 2a as 1 minus sine squared a minus sine squared a. This is just 1 minus 2 sine squared a. As you can see.
So where is the one coming from?
So look at 1. Or you mean the one on the right?
Sir, I mean the one for cos 2a is equals to 1 minus sine 2a. Where is it coming from?
So we have gotten cos squared a in its form of sine. The consequence of the first identity. If you take cos the other side, if you take sine the other side, you get cos squared x to be 1 minus, since we have a positive 1 here.
Oh, okay. Thank you.
Okay. Okay. So from this one, so far we are saying we also have this as an identity on its own. The fifth identity. This is 1 minus 2 sine squared a. Now from this one, if we solve for sine, we will take this one the other side, or we just say, okay, instead of taking one and then divide by negative, let's just take the negative one. So we take this the other side. So we have 2 sine squared a is equal to 1, and take this the other side, minus cos 2a. And then we divide by 2. We divide by 2. So what we have is sine squared a over that. So I went to play football, so I'm a bit tired. My chest is paining. So if we square root here, we square root here, we are going to have sine a is equal to the square root of 1 minus cosine 2a over 2. Then we now follow me very well here. We let x to be or we let a to be x over 2. So where there is a in this, we'll substitute, where there is a, we'll substitute x over 2. This will mean that where there is a, now look, we have 2a, and then we are saying where there is a, we should have x over 2. This means that we just have x. So if you cross multiply here by 2, you get that 2a
Sir,
is actually
sir,
equal to x. Yeah?
why are we using x over 2? Why can't we just use another number or in letter?
We want to drive what we call the half angle.
All right.
So x has become equal to 2a. So we have 1 minus cos, where there is 2a, we'll place x over 2. This is another identity called the half angle identity. For sine. So you see how they work. Don't worry. You see how you see if they become at some point. Now I want to get for cos as well. So get back to the very equation. This same equation here. We'll come back to it. Where there is sine here, we now want to substitute this form of sine. So you see why we call it the most important identity. So now it's still the same. It is cos 2a is equal to cos squared a minus sine squared a. Now let's change. Where there is sine, we put 1 minus cos squared a. Here we have cos squared a minus 1 plus cos squared a, meaning that we'll have 2 cos squared a minus 1. Okay. So if we take 1 the other side, we'll have cos 2a plus 1 is equal to 2 cos squared a. We divide by 2. We divide by 2. We'll have cos squared a is actually equal to 1 plus cos 2a over 2. And then we square root, we'll get cos a is equal to the square root of 1 plus cos 2a over 2. And then again, we let x, we let a to be equal to x over 2. So we let a to be equal to x over 2. So if you solve for x, you realize that x is actually equal to 2a. Then you come here and substitute. So you say, well, it is a, it's the same as we have x over 2. This is 1 plus, where there is 2a, we have x over 2. So have you seen the difference between cos and sine? half angle. So this is the cosine half angle. Very, very important. The difference is this sign here. If you go to cosine, you find, if you go to sine, you find the sign is negative. For cos, it is positive. Everything else is the same. Now, how do we use this? So before we get to the use of this, let's do the special. Did we guys do the special triangles?
No.
No, we didn't do them.
What about the special angles?
No. We
Okay.
ended on reference angles.
All right. And coterminal, is it?
Yes.
Yes.
Okay. So now we'll do special angles. So we have two ways of obtaining special angles. The first one is what we call a table method. Table method. You choose what you like. So you arrange sine here, you bring cosine, you bring tan, you bring sec, cosec, and cot, and put up a table or something that looks like a table. Put 0 here as an angle, 30 as an angle, 45, 60, and 90. So now I want to know what sine 0 is, sine 30, sine 45, sine 60, sine 90. So you just start counting. You say, okay, 0, 1, 2, 3, 4. And then divide by 4 throughout. Now, sine and cosine, they must do opposite of each other. So for cos, you start from 4, 3, 2, 1, 0. Divide by 4, divide by 4, divide by 4, divide by 4, divide by 4. And then get back and get the square root. So get the square root, get the square root, get the square root, get the square root, get the square root for everything. The answers you get, so here you'll get 0, here you'll get 1 over 2, here you'll get root 2 over 2, here you get root 3 over 2, here you get 1, here you get 0, here you get 1 over 2, here you get root 2 over 2, here you get root 3 over 2, and here you get 1. So all these. So now when you say sine 0, it is equal to 0. Sine 30 to half. Sine 45, root 2 over 2. So sine 45 and cos 45, they are equal. Sine 60, root 3 over 2. Sine 90, 1. Cos 90 is 0. Just like that. So what this means is that you have obtained for tan, for sec, for cosec, for cot, because we said that once you understand what sine and cosine are, you can easily use them to get tan. Tan is just sine over cos. So tan 90 would be 1 over 0, which is undefined. So write undefined.
This is nice, sir.
And so easy, is it?
Very much.
Yeah. So I use this. I think I use this In my first, I used to use this thing. It was easier for me. Okay, so now you should be able to finish for tan, sec, cosec, and cot. That's your homework now. Just remember that tan is sine over cos. That sec is just 1 over cos. That cosec is just 1 over sine. And that cot is just cos over sine. If you start with tan, when you get to cot, you just say, okay, cot is just 1 over tan. So all the other angles will come from these. So as you do them, you easily get to memorize them. They'll get into you because you need them. So for tan, what is tan 0? It's sine 0 over cos 0. Oh, sine 0 is 0. Cos 0 is 1. 0 over 1, that is 0. So that we do now another way, which is what we call the special triangles. They also help us to get these very angles. So we have the first one. The first one is for 45 and 90. So this is 90. This is 45. That too is 45. So because of 45, 45, the sides must be equal. And Pythagoras theorem says that to get the other side, you square the adjacent and the hypotenuse. I mean the adjacent and the opposite. You square them. Pythagoras theorem says you get a squared plus b squared to give you c squared. Now we have b and a, so we have 1 squared plus 1 squared will get 2. And then we square root to get the actual c. So this side is going to be the square root of 2. Now this piece is not important. Just remember that we are talking about Pythagoras theorem. And we also have this guy here, the one we call SOHCAHTOA. This one you must never forget. SOHCAHTOA will give us sine 45 opposite over hypotenuse. So n45, you get the opposite is 1 over hypotenuse root 2. If you rationalize this number, if you rationalize the denominator, it will just be root 2 times root 2, and on top 1 times root 2, so you get root 2 over 2. So it will be the same as what you obtained here. Cos 45 adjacent over hypotenuse, same thing, 1 over root 2. Tan 45, if you use triangles now, you can easily get it from here. Opposite over adjacent, 1 over 1, which is just 1. And for sure it's 1 because we are saying tan is sine over cos. So if they are equal, then you get 1. Then sec 45 is just 1 over cos 45. So it is just root 2. Cosec 45. Same thing, 1 over sine. So again, you get root 2. Then cot 45, you get 1. 1 over tan, but tan is just 1 there. So from here, you can force things. What is sine 90? You know, the opposite of sine is, because sine says opposite of hypotenuse. So the opposite of sine is root 2. And the hypotenuse is also root 2. So you get 1. But cos 45, I mean cos 90, the adjacent distance from tan, I mean from 90 is 0. Because you are at the same point. So from 90 to 90, we have 0 over hypotenuse root 2, giving us 0. And then tan 90, you are talking of sine 90 over cos 90. So undefined. Or opposite of adjacent, the adjacent is just 0. So root 2 over 0 is undefined. So tan 90 undefined, and then sec 90, you use 1 over cos, again undefined. For sec 90, you get 1. Cot 90, you get 0. Another triangle, triangle 2, the isosceles, or I can use another space. I can just put it here. Okay. Triangle 2, the isosceles triangle. Something like this. Isosceles equal sides. Equal sides. So if the angles are equal, the sides are also equal. Now look, it becomes a bit tricky. You can't use the SOHCAHTOA, but we want to use SOHCAHTOA. So what do? We come here and cut this angle here in between. So we can cut here in between, meaning that this side is going to be 30. The other side is also going to be 30. And here we have 90 and we have 90. So if I extract it from here, I can have something like this. The 30 has remained here, the 90 here, and the 60 here. With 2 this side, 1 this side, because we cut it in between, so we have 1 here and 1 here to form 2. Then Pythagoras theorem, 2 squared minus, because now we have a squared plus b squared is equal to c squared, but c is known. A is unknown, so we have a squared is equal to c squared minus b squared. Okay, so c squared is 2 squared minus 1 squared. This is 4 minus 1, which is 3. So a is going to be root 3. So we have root 3 on this side. So what happens? So this will.
Oh, no, it's fine. I just wanted to say it's equilateral. You are saying isosceles.
Okay. Oh, yeah, you're right. So, what happens now? So we have this triangle here. So say, okay, what is sine? Let's get the pairs now. What is sine 30? opposite over hypotenuse. So opposite 1, hypotenuse 2. Opposite 1, hypotenuse 2. So we have that. And then what will be cos 30 adjacent over hypotenuse? So cos 30 adjacent is √3, hypotenuse is 2. What is sine 45? Oh, sine 45 is already found. So I'm going to sine 60 now. Sine 60 is opposite √3, hypotenuse 2. Cos 60, we get adjacent 1, hypotenuse 2. So we can go to tan 30 so tan 30 is opposite over adjacent. So opposite 1, adjacent √3. Then tan 60 will give us opposite √3, adjacent 1. So you can use this now to get cosec, sec, and cot. So you can see that what you get here is what you get this side. So you choose one method that will, all these are just helping us to remember, to recall, helping us not to forget. How is it so far?
It's making sense, huh?
Okay. So I'll start picking out questions in questions on so as you write this, okay, we can move. So now we look at questions based on what we have done. I'm sampling from tutorial sheets. So I'll go to the ones that for example, tutorial sheet 8. So I just pick from any, the ones that are nice. So let me say examples. One, Find the exact values of the given trigonometric ratios. A, what is the value of tan negative pi over 6? Remember, we did how to convert. If you don't understand what pi over 6 is, you can convert it to degrees. So you'll be practicing that. So I know pi over 6 is 30. So just dealing with, this is the same as tan negative 30. Now, the quadrant, it's easier to use reference angles. So if I'm given a negative number, what do? I look for its equal terminal. So I'll say, okay, negative 30, if I add 360, it will become 330. So this is the same as tan 330. But if 330, I don't know what 330 is. But I know the reference angle of 330. So 330 is in the fourth quadrant. So the reference angle of 330 is 360 minus 330, which is tan, because here we'll get 30. So it's supposed to be the same as 30. But look, 330 is in the fourth quadrant where tan is negative. So when I switch from a coterminal angle to a reference angle, I must indicate the sign in the quadrant. So tan is negative in the fourth quadrant. Because 30 is coming from the first quadrant where everything is positive there. Remember, sine, cos, sec, cosec, tan, cot. They are all positive in the first quadrant, meaning that they are all positive for all the reference angles. So I look at the coterminal angle that I want to use in place of a negative and say, okay, the coterminal I have is in the fourth quadrant where tan is negative. So as I switch from the coterminal to a reference, I must go with the sign of the quadrant. So what does that mean? I have to switch. So say multiply, so that you don't forget, multiply tan 30 by a negative, since 330 is in the fourth quadrant. Where tan is negative. So you take note. So, but we know tan 30 is what? Let's go back the triangles. What is tan 30?
1 over root 3.
1 over root 3. So it will be negative 1 over root 3. That is our solution. B.
Sir,
Hello.
sorry, like I didn't understand. Like we have a pi over a negative pi over 6. Like how is tan 30 coming in?
So since we say that pi is the same as 180,
Oh, okay.
and so you convert pi over 6 to degrees.
Okay, sir. I get.
Okay. B sine 7 pi over 6. So look, the pi's sometimes they confuse. So say, this I want to understand. Let me change it to degrees. So okay, in degrees we said we multiply by 1/8 over pi. So the pi gets cancelled, and so 6 here, 1, 6 there, 3. This is 210. Okay, I'm doing it 210. So sine 210. 210 is already positive and within 0 and 360. So it falls in a specific quadrant. Which quadrant do we find 210? 210 is bigger than 180 but less than 270. That's the third quadrant. Okay, how do we obtain a coterminal angle? I mean, a reference angle in the third quadrant. We say, okay, a reference angle theta in the third quadrant, we get the value 210 and subtract 180. So that the angle we find is always between 0 and 90. So here we get 30. So we are dealing with sine 30. But what's the sign of sine in the third quadrant? Sign there is negative. Okay, so it must be negative. What is sine 30? It's just half. So we get negative half. Done.
Sir, so do we show the working clearly, like how we converted things?
If you're converting, okay, if not that much, not that much. But anyway, we advise that whatever working that you do, if it won't disturb you, you can present on the same paper that you are submitting for marking. But they will give you booklets in the exam, and they will keep giving you as you ask. So even if you do all your working there, they will give you as many as you ask.
So it means it doesn't earn you marks to show this part on our right.
No, for converting, no, but for the reference angle, it does.
So
The
sir,
examiner
the
knows.
booklets are different from the actual papers. We'll be writing on the correct answer.
No, you don't go with pen papers there. You just go like that. Just go with the ID and the pens. If you're too smart, you get the pens and the rule.
Okay, so in the booklet, that's where everything is done.
Yes.
Coding calculation like solving like you are making a calculator.
So like multiplying 20 by 10, there they can give you a paper where you can do a rough work.
All right.
Excuse me, sir. Like negative sine 30. Now, how are we giving the answer as negative 1/2?
Because sine 30 from here, what is sine 30? It's positive half, is it? So if you're multiplying sine by negative, the negative will just be attached to the half. Is that okay?
Yes, understood.
Good. Okay. Another one. This was B, so let's call it C. So when you catch it, I'll stop bringing examples. I'll change to another type of examples. Cos 7 pi over 3. First thing is we change 7 pi so that we can understand the quadrant where I can find it. This guy is 180 over pi, so the pi's will go 3 here, 1, 6 there. So we get 420. So we're dealing with cos 420 here. So 420, we can get the coterminal angle. We subtract, we get 60. So this is just cos 60. So the coterminal angle lies in the very quadrant where that angle lies. So no need of reference. The 60 we have is the reference angle of itself. So we just get direct what cos 60 is, and cos 60 is half. It's here. Cos 60 is half. We're done. D sec negative 13 pi over 6. So okay, what is 13 pi over 6? By 1/8 over pi. This is here 30. So we say 130 by 3. That's 390. 390. So we are dealing with sec negative 390. So when we add 360, this will be the same as sec negative 30. So we'll add 360 again. So we'll get sec 330. Then look for the reference angle of 330. We had found it to be 30. But where is 330? In the fourth quadrant where sec and cos are positive, so no need of negative. So sec is 1 over cos. And cos 30 is, let's go check. What is cos 30? Cos 30 is root 3 over 2. So we have 1 over root 3 over 2, giving us 2 over root 3. So you must understand the difference between a reference and a coterminal angle. A coterminal angle we emphasized, we said, coterminal angles share same quadrants, and so they have same properties, equal in everything, same sign, same value. Because in the same quadrant, we know the signs will be the same. The values the same because they share the same starting point and the same end point.
So,
Uh,
I was only asking, like, if you can just, Palas, at the end of the lecture, maybe you just draw like a box of the quadrants, then you just highlight some of the important things where, like, sec is negative and so that at least can be easy for some of us to get used to them.
so we bring it back. Here we said, oh, sine, cos, tan, sec, cosec, cot. In the first quadrant, we said they are all positives. In the second, only sine and cosec are positives. Here, only tan and cot are positives. Here, only cos and sec are positives. So each trig ratio is positive in only 2 quadrants. and negative in the remaining two. Very, very important. So now look at this example. Example 2. Example 2. Find the trigonometric ratios of the other 5 trig ratios given A, you are given that cos theta is equal to 8 over 17 and that sine theta is negative. What does this mean to you? The quadrant. Sine must be positive in that quadrant where sine is negative. So which quadrant will that be? So look at this. Cosine has to be positive. As you can see, 8 over 17 is positive. So cos has to be positive, meaning we're talking of the first or the fourth. And sine has to be negative. So it can't be the first. It will be the fourth. So we know in the fourth quadrant, we'll put a triangle. All the triangles must be attached to the x-axis. So this is theta here. Now cos is adjacent. So 8, because this is 90 here, over hypotenuse. So this is 17. So what is the other side? So 17 squared minus 8 squared. Then we square root. So what is 17 squared minus 8 squared?
Excuse me, sir. So the question is supposed to read as the other side, not the other 5.
It's the other 5.
It's 25, sir.
Or the ultimate answer. No, we want to show the way to. What is 17 squared?
The answer is 225.
We want to show the way to.
289
289 minus 64. Okay. So it will be 225. Which is equal.
The answer is 50.
The answer is
15.
yeah. 15. So now the question says find the other 5 trig ratios. So we have found for cos 2, what is sine theta? So sine theta, or we start counting them up to 5. So 1, what is sine theta? Opposite over hypotenuse. So 15 over 17. 2, what is tan theta? Tan theta is opposite over adjacent. So opposite 15 over adjacent 8. The third sec theta. Sec is just a reciprocal of cos. So 17 over 8. So something hasn't been done well here. So since we are in the fourth quadrant, this guy here has to be negative, is it? It's a y distance. So whenever there's 15, there will be negative. And then fourth, cosec theta. So cosec is 1 over sine, so we get 17 over negative 15. And the fifth is supposed to be cot. That is 8 over negative 15. So this is showing us that when cos is positive, for sure, sec will be positive. That's the meaning of the question. And not the other side. The other side falls in trying to find sine, tan, sec, cosec, cot. So kindly mute.
Kindly mute.
Sepiso. And then Eunice. Other questions? Okay. Let's go to B. B, cosec theta is equal to 2, and theta is in first quadrant. So what happens? Say, okay, cosec theta is 2 and in the first quadrant. Now cosec is 1 over sine. This means that sine is 1 over cosec. So it is 1 over 2. So want to use sine, we are taught in the first quadrant. So draw the triangle. It must always be attached to the x-axis. So this is theta. Sine is opposite over hypotenuse. So the other side is going to be root 3. Is it 2 squared? That's 4 minus 1. Then get the square root. So it will be root 3. So start getting what is. So already here we know cosec and sine. So we go straight to cos. Cos theta is adjacent over hypotenuse. So we can go to sec 2 over root 3 tan opposite over adjacent and cot root 3. Okay, so I've given you a hint here. Let me look for another question that requires a quadrant. So call it example 3. Example 3. Example 3. Find the exact value of the following expressions. A, the exact value of sine inverse of 1/2. The first thing you do here is you let x be this question. Now you know that we punch this in the calculator if you are looking for x. So you can also bring back the sign to x. So what is x? X is an angle. So x is equal to 30 in the first quadrant. We also have a 30 in the second quadrant. So in most cases, they will give us an interval where the x must fall. Because we have so many angles that gives us 30. I mean, we have so many angles that gives us half, depending on the quadrant. So first and second, in the second quadrant, you can get the reference angle of this guy here. So you say, okay, since we get the reference angle as 180 minus x, now we know the x. So we'll switch the x here, the theta there. So it's still the same thing, 180 minus theta. So x is 180 minus 30. So we have another x, 150. So this gives us the same half. Sine 150 is half, sine 30 is half.
Sorry, sir, would you mind repeating all that?
Okay. Sine inverse of anything. This can only be done by the calculator. When you do the second function. But we know that what causes us to do that is when you have sine x is equal to the thing inside the brackets there. Now, what you're looking for is x. So if what you have on the right is one of those things that comes from the special angles, then you can easily identify the special angle and follow the quadrant, which gives us the same sign as what we have. So in this case, we have sine inverse of half. If we let x to be sine inverse of half, we know once we find x, we would have found sine inverse. So if we bring back the sign, we have sine x is equal to half, and which x gives us a half, we know it is 30 in the first quadrant where sine is positive. If you go in the second quadrant, you find 150. If the interval is so big, you can go around and start getting the coterminal angles of 30 and 150 that are above 360. Okay, so look at this one. Tan inverse of tan 2 pi over 3. So let x be tan inverse of tan 2 pi over 3. When you bring back tan, you have tan x is equal to tan 2 pi over 3. Now 2 pi over 3 is an angle. The only way these two angles can be the same is 1 if they are coterminous. Or they are reference angles. So our first option is that x is directly equal to 2 pi over 3. The other options, we suffer if we have an interval. But for now, suffering is not good. So we avoid it.
So, sir, like if I want, I can convert these 2 pi over 3 to into degrees. It's all going to be the same, right?
And how you know which form you must present your answer is how the question is phrased. If the question comes in radians, in pies, give your answer in pies. If it comes in degrees, give your answer in degrees. Question A didn't have degrees or rad, so we chose. We went for the degrees.
What about B, sir?
So B has radians, so we can't go to degrees. We have to do everything in radians. If you convert, then your answers must be converted back to radians. This means that if they gave us an interval in degrees, would have been forced to convert the radians to degrees. If they give the interval in radians for A, would have presented our answer in radians.
I don't understand, sir.
Don't worry.
Hapa chepa. Use ya bro.
We didn't slowly. So I don't understand you back. It will come. You see when there's an interval, you will see what I mean. I'll remind you.
Now, like for example, like this guy, we are not given like we are just told to find the exact value of the expression. So I don't know.
So the exact value of the expression, since the expression involves radians, we'll leave our answer in radians.
Oh, okay. So I get what you are saying.
Sir, you mean the answer is 2 pi over 3?
Yes.
Now, sir, on the A part, why didn't we consider 30 degrees instead we wrote 150 degrees?
We considered both.
Or both?
So this is the answer or the other one.
All right.
So what you're saying is, if you haven't been given the interval, both are the answers. But if we're given a restriction, we'd pick one of them, depending on the restriction, right?
Depending on the restriction. If the restriction involves both of them, you present both of them. If you present one, you lose marks for the other.
Sir,
Yeah. You're not talking. Good. You talk when you're able. Another one, same story here. This was B. Now we do C. Sine inverse of half plus cos inverse of half. So here you let A take one form and B take the other. Okay. So if you're able to find them, this is just the same as sine A is equal to half. So A is 30. Let's use the smallest one. This is the same as cos B is equal to half. So B is 60. Don't say because I have half, so I have 30. No. Then go back to the question. It will be now the same as sine. You know A is 30, so you say sine 30 plus 60. If you want to add these, you get sine 90. And sine 90 is just 1. If you don't want, you expand. Say sine 30 cos 60 plus cos 30 sine 60. What is this? Sine 30 is half. Cos 60 is cos 60 is half as well. Is this true?
Yes.
Yes, sir.
Okay. What is cos 30? Cos 30 is root 3
Over 2.
over 2. And sine 60 is root
Same.
3
Over 2.
over 2. So we get 1 over 4 plus 3 over 4. So we have 4 over 4, which is equal to 1. So if you can't adapt to the shortcuts, you would say the exam was bulky because you expanded when you could have added. You can only know the shortcut if you've been doing so many questions of the same nature. The exam composes of 30% of new things and 70% of things that your eyes have seen before if you've been studying. And that 30% is related to what you have seen before, except that it's covered. There's like a cloth on top. So you need to uncover using what you know. Okay, so I've exposed you to this. Let's do another one. Another one. D.
Time up, sir.
Is it? No. There's still 20
No.
minutes.
Sir, continue. You can even reach at 24.
You enchant.
You were, I'm not talking to you. Son.
It's blown.
Sine this minus. Let's concentrate. 3 over 5. Whatever, guys, don't worry, we'll be done soon. So you say let A be equal to sine inverse of 3 over 5. B
So start again. I didn't get what you were saying at first.
be equal to this. So explain. I don't know what you mean by start again. So if you are given cos of this nature, you go for the inside. Let A be the first piece of the inside. and B be the second piece. This is the same as sine A is equal to 3 over 5. And this is cos B is equal to 3 over 5. Now we understand that if we are to form a triangle, and put A here, for sine is opposite over hypotenuse. So this side here would be 4. And another triangle, for cos, you put B here, cos would give us 3, 5. So this side would be 4. Meaning, when we go back to cos, we'll put A here and a B here and say, okay, this is cos A, cos B plus sine A, sine B. So what is cos A? So cos A, we calculate cos A is adjacent of hypotenuse, so it will be 4 over 5 multiplied by cos B, which we know 3 over 5, plus sine A is 3 over 5, but sine B we get from here. Hello? Hello?
I'm saying me, I'm lost. Starting from the cos A minus B, where it's coming from. And how you've expanded.
Okay. So how we have expanded. So start with where it is coming from. So I've said let A be this thing here. And this thing is this one here. So in place of that thing, we'll put A. Let B be this thing here. And in place of that thing, we'll put B. The expansion, compound identities. Where are they? They are here. Here. So we have cos A minus B. So it will be cos A cos B minus sine A sine B. Okay. So so we have cos A minus B. So it will be cos A cos B plus sine A sine B. So now we go and see how we're using that compound identity. So you find it here. You say, okay. So we have 12 over 25 plus 12 over 25, giving us 24 over 25. So this is our solution.
So I'm confused. Why did you use the 4?
Why did we use the 4? So Pythagoras theorem, if you only have two sides, you use the Pythagoras theorem to get the other side. So if you have 5 and 3, 5 squared is 25, minus 3 squared, which is 9, we'll get 16. Then we square root, so we have to square root 16. So we'll get 4 on the other side.
Okay.
All right. For trigonometry, part 2. So nice. It has to be saved. Do we have questions?
Excuse me, sir.
Yes.
Questions for the sake of practice.
I give you a question.
Just for the sake of practice.
All right.
But we can do some practice. I'm going to pass a question.
No problem.
Naikawa, fine. You want questions?
Wale kocha chairman chiruko mwacha.
Aroshana ko ka PDF file zone na ifutu mone ko intro for yake.
Okay.
Para kwa chwa kuze fingi.